This is video 6. We present here the roadmap of the article. The proof of the main result is long, difficult and requires a lot of transitional lemmas. These lemmas are gathered into different parts as shown in this figure. Note that all results of this paper can be categorized in two categories, microscopic and macroscopic ones. Microscopic results focus on a local part of an assembly. A typical example is a path assembly of length more than the size of the tiles set plus 1 contains at least 2 tiles of the same type. On the one hand, these results requires no prerequisites, but on the other hand, they deal with very specific conditions. They are not very useful alone, and their proofs are technical and could lead to an explosion of cases if the study is not done carefully. Thus microscopic reasoning is lengthy, tedious, technical and not intuitive. Macroscopic results zoom out and focus on the whole assembly. A typical macroscopic result is formulated as an assembly growing at distance lambda of the seed should respect some property p. The main result of this article is a macroscopic one. Macroscopic results are powerful and intuitive. Their only weakness is that their proofs rely on lengthy microscopic reasoning. Thus, the main difficulty is to get through microscopic reasonings to reach macroscopic ones. To achieve this aim, we develop a toolbox made of 4 macroscopic lemmas. The combination of these lemmas leads to the final result. To present all of our results, we divide the rest of the article in 5 main parts. Note that part 1 was the definition. In part 2, we present the 4 lemmas of our macroscopic toolbox and we show that this toolbox is enough to solve the conjecture. This approach is more pedagogical. The reader starts with the easiest part of the proof and the aim of the following sections have become clear. Part 3 is dedicated to a 2-dimensional discrete toolbox. Here we present some tools and results which are fundamental to all microscopic reasonings. It aims to develop an effective way to cut the grid graph into 2 areas. In Part 4, we prove one lemma of our macroscopic toolbox whose proof is independent from the other ones. This proof relies on the window movie lemma, which was already proven in the article Intrinsic Universality and Tile Self-Assembly Requires Cooperation. In Part 5, we develop a powerful tool about U-turn. This part is the longest and hardest of the proof and a prerequisite for all the remaining macroscopic lemma. In Part 6, we conclude by proving the 3 remaining macroscopic lemmas. Their proofs are consecutive. The reset lemma is required for the shift lemma and the seed lemma is required for the reset lemma. With this approach, the difficulty increases along the article. Also, this presentation allows us to introduce the different tools one by one and to illustrate them in simple cases before moving to the hardest ones.